Alright, we're now going to do the solve section. So let's start with number 23. I have 9 to the x plus 2 equals 27 to the negative x power. What I want to do is I'm going to rewrite 9 as 3 squared, and I'm going to rewrite 27 as 3 cubed. Now when I do that, I have power to a power, so I can multiply, but don't forget to distribute. So you get 2x plus 4 equals 3 to the negative 3x. Once I do that, I can cancel the 3's. So I have 2x plus 4 equals negative 3x. It's easy peasy algebra 1 here, guys. You get negative 5x, and then divide by negative 5, so x equals negative 4/5. Alright, number 24. I have 16 raised to the 4x minus 2.
Annie Lamb, please report to the front desk. Annie Lamb to the front desk, please. Thank you.
Here, I'm going to bring the 64 up because I want to get rid of the fraction. So that becomes 64 to the negative 1. Now try to break down 64. I know that I can rewrite 16 as 4 squared. And I can rewrite 64 as 4 cubed. Same thing as we did at the last problem. We have our staggering power to power rule. So this becomes 4 to the 8x minus 4. And this becomes 4 to the negative 3rd power. They cancel. So now it's easy peasy algebra 1. I'm going to add 4. So you get 8x equals 1. So x is 1/8. Alright, next one. Number 25. I have 10 to the x equals 397. Now this one's a funky one because I know 10 to the 0 is 1. 10 to the first is 10. 10 squared is 100. 10 to the third is 1,000. So right now I know this answer is going to be between 2 and 3. This is change of base, guys. So I'm first going to write it in log. Log base 10 of 397 is x. And this is change of base. I'm going to write log on top, log on bottom. 397 on top, 10 on bottom. Now, I could have just plugged in log 397 in my calculator because this is already base 10 if you think about it, right? So log 397, and your calculator does log base 10. So my answer is 2.59879. So if I'm rounding to 2 decimal places, it'd be 2.60. Which is right between 2 and 3, like we said. Now, if I wrote it as log 397 divided by log 10, look, you'll get the exact same answer. See? There it is. Alright, number 26. I have 9 to the x plus 10 plus 3 equals 84. Move it up so y'all can see. Here, I need to isolate the exponent. So I'm going to subtract 3. So 9 to the x plus 10 equals 84 minus 3 is 81. Now try to rewrite. I know that 9 squared is 81. So for this one, I can now cancel. So x plus 10 equals 2. Subtract 10. So this will be negative 8. There we go. Alright, number 27. I have 16 to the x equals 67. Same thing, right? It's going to be log of 16 of 67 is x if I put it in log form. and then I'm going to do change of base. Log of 67 over log of 16. Plug that in my calculator. Log 67 divided by log 16. Make sure I'll plug it in correctly in your calculator, just like that. Log 67 close parentheses divided by log 16. So I get 1.52 when I round. Alright, 28, I have 120 equals 5 times log base 5 of x. Now here you want to isolate the log, so I'm going to divide by 5. 120 divided by 5 gives me 24. So I have log by itself. Now I'm going to rewrite this as log base 5 of x equals 24, and then write in exponential form. 5 to the 24th power equals x. It's going to be a really big number. Yep. You can leave it as 5 to the 24th, or if you want to write in scientific notation, 5.96 times 10 to the 16th, which is a lot. So I would rather you keep it as 5 to the 24th. Alright, 29. You have log base 216 of x equals negative 2/3. Alright, so here you have, if I want to write this in exponential, you have 216 raised to the negative 2/3 power is x. Now I don't like working with negative exponents, so I'm going to bring that down. Just like that. And then I can rewrite this as 213. Right, I have a root of 213. 2 is on the inside, 3 is on the outside. So it's a cube root of 216 times 2. Now the cube root of 216 is 6. And then 6 squared is 36. So your answer here is 1 over 36. Alright, 3 more. 30. You have ln of x plus 1 equals 5. Guys, be careful. The parentheses is around the x here, because they have to put it over it all. They would have to show you if this whole thing was an argument. If they don't, you just assume the x. So I'm going to subtract 1. So I have ln of x equals 4. Now to get rid of an ln, you got to raise it. Right, raise it to the power of ln of e. Why? Because remember, ln of x is log base e, and that cancels. So here, the e and the ln are going to cancel, so you get x equals e to the 4th. Remember, e is in your calculator, it's 2.718. So it's irrational, keeps going. So that is your final answer. 31. I have log base 2 of x minus 1 equals 5. I'm going to rewrite, so 2 to the 5th equals x minus 1. And then to get x by itself, I'm going to add 1. So 2 to the 5th is 32. So 32 plus 1 is 33. Last one, 32. I have log 3x plus 1 equals 5. Now be careful. Anytime they don't have the base, you assume it to be 10. So if I rewrite this, it's going to be 10 to the 5th power equals 3x plus 1. That's how you get rid of the log. 10 to the 5th power, it's 1 with 5 zeros. I'm going to subtract 1. So what is that? That is 100,000 minus 1 gives you 99,999. And then I'm going to divide by 3. You get 33,333. Lots of 3's. Be careful on that one. Look at it so you can see it.